Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel. Now I am going to solve this problem 329. In this problem it is said that the chain binder is used to secure loads of logs, lumber, pipe and the like. And if the tension T1 is 2 kilonewton, right? So here tension in this chain is, let's say, 2 kilonewton, this is given. And when theta is 30 degrees, so this theta is 30 degrees. So we are asked to determine this force P and this T2 tension, right, for this particular position. And it is said that assume that the surface A is perfectly smooth, right? So it is said that this surface is perfectly smooth, so then there will be only one reaction, vertical reaction in the upward direction. Let's say that this is our positive x direction and this is our positive y direction, so then we can say that this is AY, right? So now we have to find this P, this T2, right? So if we apply the summation of moment at point A equal to 0, if we apply this equilibrium condition and if we assume that the counterclockwise moment is positive, so as we can see that this AY and this T2, the line of action of both of these forces is passing through this point A, so it will never produce the moment at this point A. So only this T1 and this P force are producing the moment about this point A. So as we can see that this P force is producing the clockwise moment about this point A, so we can write that this will be minus, the clockwise moment is negative, minus P, and the perpendicular distance of this P from this point A is 500 plus 100, right? So this is 600 mm. And as we can see that this T1 is producing the counterclockwise moment about this point A, and the perpendicular distance of this T1 from this point A is this distance, right? So this vertical distance. So now if we draw a triangle at this point, let's say that if I draw a triangle, if I join this AB point and if I draw a right angle triangle and let's say that this point is C, so this BC length is the perpendicular distance of this T1 from this point A. So if we write, so then this T1 is producing counterclockwise moment, so this is positive. T1 is 2 kilonewton into the perpendicular distance, so the perpendicular distance is BC, and that BC is 100 sine of 30 degrees, right? So this triangle, this angle is 30 degrees, we know this from here, right? So this BC, we can write this BC as 100 sine of 30 degrees, and this will be equal to 0. So now this P will be equal to minus 2 into 100 sine of 30 degrees divided by minus 600. So this will give us P magnitude, the P force magnitude. So this comes out to be 166.7 Newton. And this gives us P equals to 0.1667 kilonewtons, right? So when we multiply this by 1000, so then this kilo will be cancelled out and then we will be left with 166.7 Newton, right? Now to find this T2, we have to apply the summation of forces along x equals to 0. But before applying this, first we have to resolve this P force into its components, right? Let's say that this is that horizontal line which is parallel to the x-axis, let's say, which is parallel to this T2, and if I extend this arm, right, so as we can see that this arm is making 30 degrees, right? So this is making 30 degrees, this arm is parallel to this line, right? So this will be making 30 degrees here, right? And now this P force is perpendicular with this arm, and now if I draw a vertical line here, so this vertical line is perpendicular with this pink line, right? So this means that the angle between these two is also 30 degrees, right? So this angle is also 30 degrees. We can write that this angle is 30 degrees. So now if we resolve this P force into its components, so then it will have one component in this direction and it will have one component in this direction, right? So let's say that this is the Px component and let's say this is Py component, right? So Px component is the sine component, so we can write that this Px is P sine of 30 degrees, right? So now if we apply the summation of forces along x, so as we can see that this P x component is acting in the positive x direction, if this is our positive x, so I will write plus, and P is 0.1667 if we are using all the values in kilonewton, right? So I will write 0.1667 sine of 30 degrees, and then this T2 is also acting in the positive x direction, so I will write plus T2, and this T1 is acting in the negative x direction, right? So we have to subtract, so this is minus 2, and this will be equal to 0. So now we can find this T2 in kilonewton, so this will be 2 minus 0.1667 sine of 30 degrees. So T2 comes out to be 1.917 kilonewtons. So this is the solution of problem, since we are required to find P and T2.